Welcome to Func Prog Sweden 8. First, I would like to thank all recurring viewers. Welcome back, and to all new viewers, welcome to Func Prog Sweden, the meetup where we explore functional programming. And let's head over to the agenda. So today I will do a short intro by me, Magnus. Then we'll have the first presentation. Real-world functional programming in Scala using ZIO, a tour by Yonas. Then we'll go over to betting our startup on closure by Nick, and then in the end I'll do a schedule and for the rest of the year, and then a summary of today. First, I would like to thank our video sponsor, Adabeat. Adabeat is an IT consultancy company with offices in Stockholm and Vietnam. And if you want to know more about Adabeat, check them out in social media or on their webpage, adabeat.com. And if you want to support the community, which you of course want to do, head over to Meetup, join the group, or please subscribe to our YouTube channel. And if you really want to support us, head over to the merchandise store at funkprogsweden.myspreadshop.net, where you can buy t-shirts like this. We have coffee cups like this with the nice logo on. And I also would like to do a shout out to Peter in Houston. Thanks for buying one of our nice hoodies with the Func Prog Sweden logotype on. If you have questions during the meetup, don't hesitate. Ask them in the chat, and I will read it I will ask the presenter or read it to the presenter, so they can ask them ASAP, or answer them, I might say, ASAP. With that, we'll head over to our first presenter. Jonas, welcome to Func Prog Sweden.
Thank you. Excited to be here.
Yeah, it's really nice.
Yeah.
Yes. The stage is yours, Jonas.
Great.
Before Jonas will start, I will say a couple of words, and Jonas will have the possibility to hook up his laptop.
All right.
Yeah.
Let's do it.
Yes. So I'm really excited, because Jonas, I didn't know, but apparently we have people teaching Scala at KTH. I didn't know this, but Jonas enlightened me before this presentation. So I'm super happy that I found you and that you're here.
Yeah, I'm really happy to be here.
Yeah, you're welcome.
Yeah. All right.
Hit it away.
Yes. As you can see, my name is Yonas Ghidei. So I am a Scala engineer at Ziverge, which is a creator of open source library ZIO, which we will talk more about later. Previously, I was a Haskell engineer at Klarna and a Scala engineer at Rocker, and I was doing a host of different languages at Viserti before that. So I'm interested in functional programming languages, types. Yeah, I think let's get going. So first, let's talk about Scala. So Scala is a language that was created by Martin Odersky, and he set out to create a language that was wants to be a mixture between two different programming language paradigms. So he thought that object-oriented programming and functional programming are complementary rather than contradictory. And his idea was that we could use functional programming for transforming and modeling data, and we can use object-oriented programming to organize and structure our codebase. And as we all know, any language is dependent on its ecosystem, and ZIO is a next-gen framework for building cloud-native applications in Scala. And ZIO is kind of a new library. It's been around for a few years, but it has its 2.0 released a couple of months ago, and it's been rapidly growing popularity. ZIO has seen a lot of growth this last year, especially after being a challenger of the status quo from ZIO 1.0. And ZIO, the framework, gets its name from its core data type, which is also named ZIO. So it's a data type with 3 type parameters, as we can see here. And its core it's a data type. Like the core idea of it is to describe a workflow. So it has some similarities with like a promise in JavaScript or a completable future in Java, but with a core difference. ZIO is a pure value. So it's a value describing a workflow, which will later be executed, and then it will perform the computations that it describes. So this workflow can have asynchronous and concurrent properties, and we're going to look into that more later. So let's get back to the three type parameters that we see here. So we see that we have a ZIO, and it has an R, an E, and A, and we're going to go through them one by one to explain what they mean. So the A here is the success type. So this is the type of the value. This is the type of value the ZIO-REA can succeed with. So when this computation or this workflow has finished running, or when or if it has finished running, it will succeed with this value A. And E stands for the error type. So this is the type of error the workflow can fail with after it has finished running, or if. And lastly, the R environment, the R parameter, which is the environment type, is the contextual data needed to run the workflow. So a helper conceptual model you can think of this is a ZIO-REA could be thought of as a function from R to an either EA. So given on R, it can produce eventually a value of A, or it can fail with a type E. So this is not an exact, precise representation, but it can help you think about how this will work. All right, so enough of the conversation here. I think we should go ahead and do some live coding to showcase how ZIO works in the real life. And while we're at it, we're going to take a look at some of these different bullet points here. So we're going to take a look at code organization, and we're going to have in mind what we talked earlier about what Martin Odersky set out to create when he created Scala, how he wanted to use object-oriented programming for structuring your code base, and how ZIO leverages that vision. And then we're going to take a look a bit on dependency injection, how ZIO does that for you, and then some common everyday use cases like error handling and retry policies. Okay, and we're also going to take a look at testing if we have time. So we're going to see how we do that. Okay, so let's head over to Visual Studio Code here. I'll change this to full screen. So for the non-Swedish viewers, we just had an election in Sweden. So I thought it'd be fun to build a kind of, let's call it decent election system to showcase ZIO. So we're going to take a look at that. So I think first, let's run. I think we can take a look at that by just running. So let's run main, and then take a look at the HTTP server here. So we're going to start our server, and then we can explain it as we go. So we're going to head over to localhost 8080 docs, and we're going to take a look at what we have here. So our application is an election system that exposes 3 endpoints, and they're going to be get endpoint to retrieve a vote based on your national identification number. You're going to be able to create a party using this put endpoint by specifying the party name. So we have some example data here. This Func Prog 2022, and then you're gonna be able to also create a vote here by specifying your name, last name, national ID number, and also the party you want to vote for. Okay, so this is like the end result. This is what we want to accomplish. Okay, so let's head over back to the code. Before that, actually, let's stop this server and also switch branch to presentation. So I prepared a presentation branch that stubs out some of the implementation so that we can finish the project together. Okay, so before we go ahead and look at the source code, I just want to quickly give you a look on our database model. So we have 3 tables: a person, a party, and a vote. Okay, so a person, as we saw before, is a first name, last name, national identification number, and then a party has a party name, and then a vote. You can register a vote based on your national identification number and also the party you want to vote for. So nothing fancy going on here, just to give you an intuition of our domain. Okay, so let's orient ourselves in this code base. this is using standard SBT Scala structure. So we're going to go to source main, and then we're going to look under Scala to find our sources. And we have a few different packages. So we have config, and we have a database service, and we have our model, and our model represents our data types that we saw. So we can take a look at, for instance, a vote. You see here that a vote is composed of a person and a party. And if we look at party, you're going to see the first name, last name, and a national identification number. So NIN is just short for national ID number. I was a bit lazy when writing this code. All right. And then we have also our routes, which is our election server. And this is the code that writes that writes this. So the endpoints. So that describes these endpoints and the handlers for them. And then we have a validation package, and we're going to get back to why we need that later. And here we have our main election service. So this is where the bulk or the meat of our code is going to lie. So this is the stuff we're gonna implement, and I am just going to minimize this as to not distract you from stuff you're not ready to see it. So, okay, so let's take a look at this. Okay, so we have a trait. So a trait in Scala is an interface in Java. So and also we have an object, and this is the way you create singletons in Scala. So the way the singletons are used are for namespaces. So you can put stuff related to the election service in this namespace here. So we're going to see what kind of stuff we're going to put here, but it can be data types related to the election service and stuff. Okay, so before we're going to get into that, we're going to take a look at our interface. So this election service has 3 different methods. Okay. And it has, so the way you read this is that this is a definition. So this is the name of the method. This is the parameter list here, and this is the name of the first parameter called party, and the type. So the way you read this is, I have a parameter called party, and the type of that parameter is also party with capitalized. And this is what we looked at earlier. So this is just a class with a party name, one field. Okay, so, and this is the return type. So the return type is a ZIO. So remember that the first type parameter was for the environment, the middle type parameter is for the error type, and the last type parameter is for the success value. So the way we read this is we have a ZIO that can run in any environment. So what we're doing here is we're cleverly using the Scala type system to signify a workflow that can run in any environment. So this ZIO does not need any additional contextual data to be run. And also here, if we look at the error type here, it's typed to nothing. And again, we're using the nothing type because the nothing type in Scala has no values. So if we have the error types typed to nothing, this means that we have a ZIO workflow that cannot fail with any typed error. Okay. This does not mean, however, that it cannot fail at all, right? We're still bound by the reality of the world. So if this machine has an out-of-memory exception or a real fatal error, then of course this is not going to succeed. But we want to, in ZIO, we think it's useful to separate those 2 errors. The failures that we cannot deal with, and the domain errors that we do, in fact, want the upstream to deal with. So, and then the return here, the success value would be a party. And then we can take a look at the other 2 methods. And again, those are very, very similar. So the difference here is that this one, register vote, can fail, can in fact fail with a domain error, and that will be invalid input. And we'll take a look at that later on. Okay. And also for the people not knowing what unit is, this is the type void in Java. So this is just a value with no additional information. So yeah, we'll take a look at that later on too. Okay, so let's head over to this singleton, and we're gonna try to implement. We're gonna do this, and we're gonna take a look at this here. So what we're trying to accomplish here is that we want to provide an implementation for this interface. So as we talked about earlier, we're gonna see how we're mixing OO features and functional programming features. So here we're back to OO. This is interface OO, and we're gonna see that we want to implement this interface. So the way you read this is that we have a class that we call election service live by convention. So this is what we do in ZIO, and we extend this interface. And as we can see here, we have two parameters, the database and the validation service, in order to implement these methods here. So let's go ahead and take a look at this implementation. We're going to try to implement all these members. And we're going to wait with get vote and only do that one if we have time. But otherwise, we're going to focus on create party and register vote. So let's start with create party. I'm also going to remove the tree here on the side to give us more space to look at the live coding. So I hope this is a bit better. Okay, so we have this. We want to make an implementation for this, create an implementation for this create party, and yeah, we have what we have is a party in the parameter list. And spoiler alert, we're going to use the database to register this party. So we're going to go to database, which is the database service here. So we're going to use this one, and then we're going to do dot, and we're going to use our dot completion here, dot. And we're going to see what kind of methods this database service exposes. And we can see here that it's exposing insert party. This one looks like the one we want to use. And then it takes one parameter. So we're going to pass the party. And now we have a type error. So let's look at the type error here. We have, the Scala compiler is telling us that we have found a ZIO that can fail with a unique constraint violation. But what is required is a ZIO that cannot fail with any type error. So the Scala ZIO is cleverly using the Scala compiler to tell us at compile time that we have not handled all errors. Okay, so let's see what kind of error do we have. We have a unique constraint violation. Okay, and if we go back to the endpoint, we can see that we have a put endpoint for this for creating a party. So that means that if the party already exists, we should not treat this as an error. We can simply say, okay, this endpoint should be idempotent. If that party already exists, then then it's fine. We can just say, okay, let's move on. We don't have to fail on this error. So let's recover on that. And the way we can do that is by using the catch-all combinator in the ZIO on ZIO. And the catch-all combinator expects you to recover from an error, E, we can call it E, and a unique constraint violation. And this is the function. So in this function body, we have to supply a function that will recover from this error. Okay, but there's not too much to do here because we already know that this is not a problem for our application. So we can just, if we're interested, we can log this. So we can use ZIO.log info and say had unique found error, got error E, and just say ignore or something, ignoring. Okay, and yeah, and then we can save that and see what the compiler tells us now. So again, there's something wrong. We have given this function a ZIO of any nothing unit, but it expects us to give us a party. So here we're saying that, okay, if the party already was inserted in the database, we can just simply return the party that you tried to insert, which should be the same, right? So what we can do is we can map over the ZIO. So we can use map, and then we can say that we can give this success value a name. Let's call it unit, and then return the party. So we can see here that this unit, this is useless information. So as we said, this is void in Java, so this doesn't help us in any way. We're just returning party anyway. So what we can do is we can use the underscore in Scala, which is don't care. So we can have a map. We can map over this unit and discard it and just return party. And this is very common in ZIO. You see this pattern a lot. So you can just use the as operator. So we can just do as, and then we'll return party. Okay. So now we're done with create party, and now we're gonna head over to register vote, which is a bit more involved. Okay. So let's first read the comments here. We have what we want to do is log an entry that we've entered this function body. Then we want to validate the vote using the external vote validation service. And after getting a response, we want to handle the response. Okay, and we can see here that we have a validate vote helper function and a handle response helper function. And we also have this what we call in Scala a for comprehension. So a for comprehension is, in Haskell, it's called do notation. So the way you're supposed to read this is that this happens first. The return of this is something we're discarding. So logging just gives us unit. So we're going to discard that. Then we're going to head over here and validate the vote. And then after that, we're going to get a response after validating the vote. And then we're going to use the response in handle response. And then the result of that, we're going to discard. And then this entire for comprehension is going to yield or return unit. So this is the unit value. So this is the value unit of type unit. Okay, so we could return anything we want here. We could put vote here, but it's not interesting. So we're just going to put unit here. Okay, this is also another way to think of this is that this is syntactic sugar for two flat maps in a map. So basically, we could rewrite this code to be a bunch of flat maps and maps. So we could say underscore, and then we can validate the vote like this, like that, flat map, etc. Right? And then this would be the response, and then we would handle the response. But as we can see here, this is what is sometimes called callback hell in JavaScript, and this doesn't look too good, so we'd rather use the for comprehension that we have in Scala. So another reason for you to switch to Scala if you're using JavaScript. All right, so let's head over here and implement validate vote. So we're going to take a look at validate vote here. We have a vote as the parameter, and our return is going to be a ZIO that can be run in any context, can fail with no errors, and will yield the validation response. And we can use the external validation service to do this. So let's do the validation service. We have it here. So this is passed in the constructor. So we're going to go back to validate vote, call validation service, and then we're going to, again, do dot completion and see validate vote. We're going to use vote, and we're going to pass the vote there. And again, we're going to get help from the Scala compiler. So the validation service, which is an external validation service, can give us a validation error. And we're going to take a look at that data type and see what that is. So a seal trait in Scala is a way to do a closed enum. So the way you should read this is that we have a validation error type, and it can be either one of two things. It can be a temporary error or a response error. And the way we're going to think about this in this domain is that this temporary error is an error that might go away if maybe we try again. And a response error is something that we can't really deal with in our code. We're going to probably need some manual intervention to deal with that. Okay, so let's go back here and handle this validate vote. So what we can do in ZIO is we can use a retry operator to retry. So we want to deal with, if there's a temporary error, we want to retry our call to this external validation service. Okay, so we can use the schedule data type to specify our retry policy. So here we can use, let's say that we want to retry 5 times. So let's do that. So we have a schedule that, so our retry policy right now is that we were going to retry this vote 5 times. But we're going to retry this as fast as humanly possible, okay? And that might not give us time to recover, that might not give the external validation service time to recover from whatever temporary error they're experiencing. So we want to space these retries. So the way we can do that and compose policies is by using the and operator on schedules and use the spaced operator, and then we can provide how a long time we want to space. We can use just 10 milliseconds. I'm just using this arbitrarily. We can specify whatever time frame we want. Okay, so we have one more thing to do, and that is that currently we're retrying on all validation errors. But I already said that we only want to retry if the validation error is temporary. So the way we can do that is by combining the schedule with another schedule. And that we can use the recur while operator. And this will, so then we can specify that we only want to recur while the validation error is temporary. Okay? So we can see here that we have a schedule. We have a schedule that will recur 5 times. Maybe I can zoom out a bit. So we have a schedule that will retry 5 times, and it will space the retries with 10 milliseconds between each retry, and it will only do so if the validation error is temporary. Okay? And you can see here that the Scala compiler is telling us that we still haven't handled all errors, right? So if this happens for the 6th time, then we're going to still have a validation error. Or if we never had a temporary error in the first place, maybe we had a response error, then we still haven't dealt with that. And ZIO, and we already know that, okay, if the external validation service is down, then it's down. We can't really recover from that. So ZIO allows you to just say that, hey, we can't recover from these failures, so we're going to die if that happens. So the way you're supposed to read this is that we're going to validate the vote, and we're going to retry according to this policy. And if that doesn't work, then we've done all we can do. And then in that case, we're just going to die. And what die does is just moving the error channel, the validation error, to the untyped error channel. So it's going to be moved to all the errors that we were not interested in keeping track of. So all the fatal errors or all other errors, right? So because the upstream can't deal with that error either. So it's just time to give up and say, hey, let's move on. Okay, so now we've implemented validate vote. So we want to implement handle response. Okay, so let's take a look at if we get a response, so everything succeeds, we're going to get a validation response. And this validation response is, again, an enum, and it's going to tell us whether the vote is valid or invalid. So we only have 2 cases. So what we're going to do is we're going to match on that. So we're going to do match, and the language server is helping us and showing us all the cases. So this is a exhaustive pattern match. And we're going to, I like having the name before, so it makes it super clear. So we're going to add response valid. And then we're going to do question mark, question mark. And question mark in Scala is just throwing an exception. What is not compiling here? We'll start simple pattern. Nope, that was an old error. Okay, yeah, cool. So I'm just going to remove this. Just going to remove that. So let's take a look at this again. So what do we want to do? So yeah, question mark is just is a way Scala to just specify that we want to do something in the future. We don't have an implementation. This is just going to throw in not implemented error. So nothing going on here. So what do we want to do if the vote is valid? So if the vote is valid, then we can safely go to the database and say, just insert this vote into the database. So we're going to do that, and perhaps we want to do some logging. And the way we can do that is we can, if we want to combine 2 ZIO workflows or descriptions together, we can flat map. So we can flat map them like this. So inserting the vote into the database is not going to give us any interesting result. It's just going to give us a unit. So we're going to discard that unit. And then we're going to maybe do some logging, say ZIO login info. Inserted vote to database, something like this, okay? But again, this is another common pattern in ZIO where you flat map and underscore, and ZIO has a shorthand way of doing that. So we can use the shark operator here, the right shark operator, to do this. So this is a much cleaner way. So the way you're supposed to read this is that do this first, discard the result of whatever that is, and combine it with this ZIO workflow. And now we can head over to what we want to do if the vote was invalid. So if the vote is invalid, then we can't do much more, right? We want to tell whoever made the call to register vote that, hey, this vote is not valid. So we're going to use the ZIO.fail operator, and then we're going to use error invalid input, and we're going to say vote was not vote was not valid. And you can see here in the type parameter that this is being caught by this is shown in the contract of this function, that this can fail with invalid input. So if I were to put a different error here, then this would not compile. Okay, so yeah, we are done implementing this. We're done implementing this function, register vote, and I'm going to skip get vote, but we can get back to this code. You can find all this code on GitHub later on. So I'm going to post this and make it public, so for everyone to see if they're interested. But yeah, it would be very similar to what we did for create party. We just make a call to a database and do some mappings. All right, so we have one last thing to do here, and we're going to talk about something called Z-layers in ZIO. And a Z-layer here is so if we first talk about OO constructors, so if you look here, we can see that we have an interface, and we have a class implementing that interface. Okay, but we are all functional programmers here, or interested in functional programming, and this is not a value, right? I cannot store this election service live in a value and modify it, pass it to a different function, right? So since we are functional programmers, we want to get back to the land of values. And ZIO has a concept called Z-layers, which is a constructor as a value. And if you kind of squint at this, so it also has, this Z-layer has 3 type parameters. It has the environment type, the error type, and the success type. But instead of describing concurrent and async workflows, this is describing the construction of services. So we can take a look here. If you squint a bit, you can see that these two lines are very similar. These lines here, this line here, implementing the interface, is very similar to this Z layer. What we're saying here is that this Z layer, given a database and a validation service, we can produce an election service. And we're actually saying the same thing here in Scala. We're saying, given a database and the validation service in the constructor, we can provide you an implementation of the election service. Okay, so the way we do it, the way we do the same thing using Z-layers is that we call the apply method of the Z-layer, so the construction method, and we again go to a for comprehension, and then we say that we want to have, if we have a database in the environment, so let's do this, election service live, database, then we're gonna copy that, validation service. Okay, so what we're saying here is that given a database and a validation service in the environment, this is how you create an election service. So here we're extracting these two, the database and the validation service, from the environment of this Z layer. So we're not really saying how we're going to construct a database and a validation service. We're just saying that if we had those two, we would be able to create an election service. So this is the way you're supposed to read this. Okay, and now we're done with we're done with the election service, and I'm gonna quickly go through how to wire up our program or our entire application. So let's head over to main. Okay, and so we have our program in app. So this is just starting the server and stuff like that. So we're gonna call that. We're gonna call app.program, and we're gonna save. And this is using, so what we're doing here is we have extended our main with a ZIO main. So a ZIO main is going to expect a ZIO that that is ready to be run. But this ZIO is not ready to be run because we have not specified how we're going to construct all the services that we have used in our program. So in order to specify that, we need to call the provide operator. So we're going to save here, and look what's going to happen here. We can hover, and we're going to see that we have compile time using Scala metaprogramming. We have a compile time version of our dependency graph, and ZIO knows exactly what services you need to provide in order to be run. So there's no surprises at runtime. So we can see here that first we're going to need to provide some configuration for our HTTP server. So that is not very interesting. So I already prepared that beforehand. So we're just going to provide default settings, and now we're going to take a look at the more interesting stuff. So Z-layer, we have a Z-layer error, and it's saying, please provide layers for the following two types, the election server and the app config. Okay, and if you go back to the election service, we can see that we called our live layer, we called it live, and we put it in the companion object of this interface. So by convention, we can look at the companion object of those two services, the app config and the election server. So let's start with the app config. So we can do dot, and we can see that we already have a live layer there that I prepared beforehand. And then we have the same for election server. So let's provide that one. And look what happened now. So now we got a new error saying that, okay, you provided the election server, and now that in turn requires the election service. So the election server here requires election service. So we already have one. This is the one we implemented. So let's also provide that one. Let's see what happens here. So the election service .live. So now that we provide that one, again, now it's going to say, hey, in order to create the election service, the live version of it, we need the database and the validation service. So now we're back at how we're going to provide these things. So let's do that. Again, by convention, we know that the live implementation is on the companion object of database live. And we also have the external validation service. Then we can provide the live implementation of that. And now this compiles. Okay. So this is very interesting. So let's take a look. we have a way to actually make this a bit more interesting by using Zlayar debug and tree. And if I save this, we have just, is it possible to make this a bit bigger? Yeah, great. Okay. Now we can see that ZIO is actually printing our application's entire dependency graph. Okay? So you can take a look here. You can see that here are the HTTP server settings, the default settings, and here's the app config. So these are these are layers that does not depend on anything else. So these are just layers that we can just provide out of the box. But the election server here is depending on the election service. And the election service, in turn, depends on the database and the app config. And if we look at the validation service, the election service depends on the validation service, which in turn also depends on the database, which in turn depends on the app config. And if you take a look here, you can see that we've only provided the database once, right? Even though it's used and app config as well. So even though app config is used in multiple places, we've only provided it once. So the ZIO will take care of your entire dependency graph for you. It will automatically initialize all of these services, and then in a resource safe way, and it will close them. And it will also do so in parallel. So as you can see that the HTTP server settings and the app config, they don't depend on anything else. So they can be created in parallel. And ZIO will know this and take care of that for you. And also, another thing here is that we can provide these in any order. So I can put database at the top, and it will still work. So what we have is compile time dependency injection, and we have great error messages guiding us in an iterative fashion to provide all dependencies. And then we also have parallel initialization of our services. So this is some of the things that ZIO has to offer, and I think we can head over back to the slides. Let's look here and then play this again. And yeah, hopefully I've shown you the way ZIO and Scala goes hand in hand, and that ZIO can leverage Scala's type system with the bottom types and the top types to provide you really nice error messages while you're doing your everyday coding. And yeah, and I think ZIO kind of fulfills this mission that Martin Roderski had when he set out to create a language that uses two big paradigms that had not really been combined before. And if you're interested, I will publish the source code at my GitHub here, github.com/Ghidei. This is my last name, and then you can just look for Func Prog 2022. And if you want to take more look at ZIO, you can head over to the official documentation at zio.dev. And this has seen a really big, massive overhaul the past few months. So you should really take a look. It's really comprehensive. And I think that is it for me.
Thank you very much.
Yeah.
Yes, great. And of course, we'll publish all links, everything below the live recording, and also below anything we publish. We had one question actually.
Mm-hmm.
They wanted you to show testing.
So
head back to the code and show some testing.
All right. So let's do it.
Yeah.
Okay. So
we got one request. Can you show testing in Scala? And I said it will come later, and now now it's later.
All right. Okay. So
and then I will hit you with some other questions.
All right.
Start with that.
Okay. Cool.
Yeah.
So I'll quickly. So we already gone through. So maybe I can make this full screen somehow. Or no, it is full screen. Okay. So what we can see here is that what I'm using to test my stuff is a library called test containers, and it's a really awesome library. It spins up Docker containers for so you can test your code, and it handles that automatically for you, and you can do it programmatically. So what we're using for our database is Postgres. So I'm depending on ZIO test containers for the Postgres module, and all I need to do is provide a Zlayar for how to go from this container to this database config, which is what my database depends on. So if you look at the database here, so my database, I have a layer for it, which depends on the database config. So this will specify the URL and username, password, etc. So let's not dwell on that too much, and take a look and write a test together. So we're going to be using ZIO test, and there's a cool concept in functional programming, which is called property-based testing. So what we want to do is we can write the first test, which is we should be able to insert a party. So what we can do is we can again create a for comprehension. So let's do database insert party, Okay. Insert party, and I'm going to say vol party equals question mark, and then I'm going to yield. We're going to just quickly say assert true here, true, and I'm just going to import. Okay, so and we're going to pass this party. Okay, so let's get back to property-based testing. So what I could do is I could create a party here by myself. I could say party name foobar here, okay? But this would be very tedious. First of all, I would only be testing. So imagine that in our database, maybe I can only insert parties with characters less than 10 characters, right? And if I would do this, then the test would pass, okay? But I would not know that I had a max limit for more than 10 characters. Maybe my database doesn't support all characters, okay? And so in order to test those edge cases, we don't want to spend time creating 20 different instances of party and manually changing the characters. So what we can do is we can use property-based testing. So property-based testing is, I prepared this beforehand, so we can call the generators object that I have here. We can take a look at that later. So what we can do is we can say gen party, and this check operator will expect us to provide it to test given a party. So we will have a party here that has been generated by this generator. And we can use that to pass the party. And our test here is that we just want to say that this database, this insertion succeeds. So I don't have a value here to test, right? I only want to test that this insert party succeeds. So I can just do assert true and then pass true, right? But there's a shorthand for this, so we can just say assert completes. So we can just say, I just want to assert that this insert party completes, okay? Maybe there's a assert succeeds even. No, so completes is the one. Okay. So let's go ahead and run this. So we're going to head over to the terminal. We're going to go to the SPT console, and we're going to say test. And maybe I need to reload. Okay, cool. So let's do it. So I have some warnings because we're on the presentation branch. Okay, yeah, this does not run. And the reason it did not run is because I have a ZIO aspect on add ignore, and we don't have time to go through what ZIO aspects are, but these are pure value function transformations. So this is not any Java hack. This is a pure value, and we can actually see here. So this is just a function. Okay, so we can inspect the code. So I'm gonna remove that annotation, and we're gonna run this test again, and okay, yeah, this is actually interesting. Good that we saw this. So look at the error here. The error is that we have a unique constraint violation. So remember that so this is something that this is very good actually. The property-based test actually found an error here. So what it did is that it generated parties with the same name twice and inserted it in the database. So we're actually running this like hundreds of times. Okay. So it actually found an edge case where if I insert the party with the same party name twice, we're actually going to fail. So if I only created a party like I did before and passed a party name, then this test would have succeeded, because I would not have tested the edge case where I'm violating the unique constraint violation. So the way we can do this, fix this, is by I have a package private delete all rows. So if I delete all rows before inserting a party, then we can actually test the invariants that we're looking to test. So let's do that. Let's run that again, and you can see that this test actually took 2 seconds, and the reason for that is because we're running this with a lot of different parties. So maybe, yeah. So I hope that was a quick peek of how that works in Z.
Thank you very much. Yeah, I hope. It looked very good,
yeah.
Actually. I myself have a background coming from testing, so it looked very good. Very nice. Yes, let's see. We haven't received any more questions, so I will shout, or I will ask some questions, not shout. First, very courageous to live code.
It went well, though.
Yeah, it went well. So well done, really good done. It's always like bit where it doesn't compile it.
Exactly.
Everyone else sees it. Really courageous. How come you went into functional programming in Scala in the first place?
Well, as I said before, I did my master's at KDH, and there is a professor there who is one of the creators of Scala. He's like a big contributor to Scala too,
Mm?
and he was a professor there and had an interesting course in compiler construction, and that is how I got into it and kind of been hooked ever since.
Mm. So you got hooked.
Yep.
And after that, it's kind of
Yeah,
you're into Scala.
of course.
Yeah.
That's how it works.
How come you find or found Ziverge, or they found you?
Well, as I said, I've been a huge fan of Scala for a
Mm.
very long time, and then there was this new library called ZIO, and it was creating a lot of ruckus in the Scala community. It was coming with a lot of innovation, so I started following that ecosystem very closely when I was doing Scala. So I was doing Akka before at work, and then I asked for permission at my work to create a small microservice using ZIO. There was not a release for 1.0 yet. It was like a release candidate.
Mm.
So I created a small microservice using that, and then I just was super interested in ZIO, and then I applied for the company. Yeah.
Here you go.
Mm-hmm.
See, really nice.
Yeah.
Again, thank you. It was really nice presentation. I liked it a lot. We don't have any more
Thank you.
questions, so
Great.
again, thank you very much for your presentation.
Thank you.
you very much. We'll put it out as we said, and we'll post all links and everything, so you can find the code.
Yeah.
You can go there and hack away yourself if you're interested.